It's my pleasure to be here. I really enjoy what I've been hearing. I think a lot of speakers have given us a lot of very innovative and macro theme, and also about how technology can be very disruptive, and we all have to adapt. So what I'm trying to do today, it would be maybe rather than talking about macro themes, which I think we've covered quite a bit already, I would like to share with you some of the experience that we have been having in doing what we do, which is asset management, and how we actually use technology and how we have to adapt and change in what we've been doing over the last 20 to 25, 30 years. So a quick background. At Man, we manage around $80 billion, and as you can see in the first line, we call ourselves a technology-empowered active investment management firm. So technology is really, really important for what we do. And of the $80 billion under management, half the assets between AHL and Numeric are running quantitative strategies. So when I joined AHL 26 years ago, really what we've been doing is trying to use technology and computing models and looking at data to try to forecast market better and try to allow us to basically make money by getting market direction correct. So really technology is core to what we do. So I'll touch on a few different themes, example of open source revolution, and then I'll talk about big data, we'll talk about computing power. But really what it will lead on to is I'll talk a little bit about artificial intelligence and machine learning and how we actually use it and what are the challenges. How do we, when we're using it day to day, what do we do and what are the issues? So open source software, let me just define it. It is a type of software that really is free for everyone to use. It's being developed by many people around the world. A lot of people contribute to that. No one really owns the software, so hence it's called open source because it's really open for anyone to use. So as an asset manager, we do use a lot of technology, and what we're finding is that using open source software, it can allow us to reduce the cost that we have to develop and also maintain. It will also quicken really the speed that we can develop our software. But actually also nowadays, the people actually, good technologists, they are adopting open source technology. They really love this way of working. And hence, if we want to attract the best people, we have to be also contributing to this. So really open source, to get the most out of it, you also have to not just taking from the open source community, but also contribute back to the community. So a bit of a history really is not a new thing. Certainly when I started working back in 91, already we have seen the first few examples of open source. I'm sure most of you probably have heard of Linux or Python. Actually, Linux basically is the basis of the Apple iOS, and actually a lot of companies are using Linux as their operating system. And over the years, I mean, we have, I think community have changes from really in early days, they're very suspicious of open source. Why? I mean, nothing is free, right? So if something is free, something must be wrong. We're sharing this with everybody compared to owning your own software, developing your proprietary software that no one else will know about. That clearly is a lot safer. So that's why people have buy kind of third-party software, they develop their own proprietary software. And at the beginning, really, people feel that if they have to contribute, if they have to use something that everyone can see, that's dangerous, and there are issues about it. But actually, over the years, things have been changing, and really in the 2000 onwards, I think companies actually starting to use it quite a bit. And actually, over the last sort of 6, 7, 8, 10 years, a lot of corporates are now actually contributing back to the open source software, including ourselves at AHL. We have contributed 2 major packages. We've been using open source for many years, and we've actually released sort of big packages that we have been developing ourselves to the open source community, so everyone can actually use it, and it's free. And not just us, but actually you'll find open source software in many, many places. So 99% of the top 500 most powerful computing system, they're running Linux, and that's open source software. Major financial exchanges, they're all running this as their mission critical system. And there are many companies, Intel, Samsung, and Microsoft last year basically have signed up to Linux Foundation. So again, being a company that have been trying to really make money by selling their software, they have now adopted the open source approach. For what we do in trying to perform data analysis and try to really do research on data, we use a lot of open source software which supports data capture, data storage, data manipulation, and time series analysis. So the benefit of why we do this is actually open source because it's out there, because everyone can see it. All the communities, all the software programmers can actually go and use it, and they can test it. When they find something wrong, they can actually go and fix it. So actually there are many, many people. I imagine basically that there are thousands and thousands of people who are all trying to work and improve the software. And when something actually goes wrong, a bug goes wrong, then so many people competing trying to fix it. So actually you can have very fast turnaround. And clearly there's huge community out there. And in terms of costs, it's practically free, although actually you also do use services and consultancy company to try to help you to try to get the most out of open source. So it's not completely free, but actually compared to this third-party software in the old days, it's much cheaper. So if I just take a look at one of our own kind of examples, so this open source software called Arctic that we developed, compared to the earlier software that we've been buying and paying license for, let's just look at some comparisons. So the issue here, what we're trying to do is basically we try to store many tick data. So all the exchanges around the world, every second, every microseconds, there's some transaction. We try to get all this data and we try to store, there's a terabytes of data, and then we try to retrieve them quickly. We then need to basically do analysis on them. So in the past, we bought a proprietary software, which is proprietary. It's sold to us, but also sold to many people. So clearly, it's aiming for a much broader audience. But when you actually look at the actual performance for what we try to do, you can see that the performance, is more than 10 times better, using open source software compared to our last third-party software. And also, it's much cheaper. We're paying over $200,000 a year just to support that and pay license fee. And with open source, basically, we spend a couple thousand to basically maintain certain necessary kind of licenses. And so that is really the first thing about that has been impacting us in technology world over the last 15, 20 years. And I think that carries on the theme that we've been hearing about, that the new world is much more about community, and the internet really enable many people to collaborate, and open source is a very good example of that. So let me talk about the next topic on big data. I think you heard a lot about it. In financial world, we use Bloomberg, we use Thomson Reuters, and these are traditional data provider. However, nowadays there's some emerging kind of niche player also providing a different type of service. So we have Cancel, who actually try to provide data service using kind of Google Trends and Google data, this kind of big data to try to help financial company do analysis. We have Enigma, which is trying to pull together all the world's free data set and then offer them as a package. Quando is very interesting. It's trying to take a bit of an open source approach. It's a community contributed data set. So people can contribute data and they try to just maintain it for free. So everybody can try to contribute and correct the data. But there's some interesting data in Quando, for example, death on train tracks or the river water level and things like that, which, in a big data world, I think these are really changing the way we do our analysis. And so how big is big data? So big data is big. These data figures are a bit out of date, but a couple of years ago, I think IBM talked about 90% of the data that exists, all the data that exists today, 90% of them was created over the last 2 years. I think the percentage is probably higher today. And if you look at what we have been doing, so back in 2015, in June, we're collecting about 800 million price points per day. By beginning of last year, we're collecting 2.2 billion already, and now we have I think the number's gone beyond kind of 3 billion price tags per day. So we need a lot of space to basically store this data and also have the machinery to analyze them. But not just the volume, but also I think the variety of data now is actually very rich. So you can have satellite data. Government put a lot of their data on their website. You can basically use collect basic consumer information via kind of credit card transaction and all that. So there are many different types of data that are available for us to do our analysis. That changes the way that we can use data to do our financial forecasting. So in the past, we use prices, we use company balance sheet and all that. But now, take an example of what we've been doing in our long-only equity investments. So basically trying to predict which stocks is going to outperform the peers. So we've been looking at using Google Trend or other big data, social media and all that, trying to forecast basically where is the consumer interest. So for example, if suddenly luxury handbag is becoming very popular search on Google, does that mean that basically people are likely to buy more luxury goods? And does that mean that luxury good companies are going to outperform other companies? So these are basically the new way of actually using data to do financial forecasting. And then on to basically computers. So I'm sure you've all seen this chart, which is talking about Moore's law. Computing power basically double. Basically every year. It's been true for a very long time. However,